Hi everyone. In this video we're going to be looking at how we can balance redox equations. So in order to balance redox equations, we need to first separate our equations into two half equations, and then we're going to do the following steps. The first thing we're going to do is we're going to balance our main atom. Then we're going to balance our oxygen by adding H2O. Then we'll balance our hydrogen by adding hydrogen ion. And then we're going to count the charges on each side of our equation. And from that, we're going to add electrons to the more positive side. So we're going to do this for the following equation. In this equation, we have antimony reacting with nitrate, and it will give us antimony oxide and nitric oxide. Okay, so as you can see, this is an unbalanced equation, and we're going to need to separate it out into two half equations. So we're first going to start off by separating out the antimony equation. So this is what we've got so far. We've got antimony and antimony oxide. Remembering those rules, the first thing we're going to do is to balance the main atom. So our main atom in this case is antimony, and we can see that there are 4 on the right-hand side. So we need to add 4 onto the left. The next step is for us to look at those oxygens. So we're going to balance the oxygens by adding H2O. So on the right hand side, we can see that we have 6 oxygens. So we're going to need to add 6 of those water molecules to balance out those oxygens. So now we've added hydrogens into the mix, we need to take care of them. So we'll rewrite the equation, and as we can see, we've got 6 water molecules, which means we have 12 hydrogens on the left. So in order to balance those hydrogens, we need to add some H plus ions, and we're going to need to add 12 of those, and that will balance out all our atoms. Now, because we're talking about a redox equation, we now need to look at the charges. So we're going to rewrite the equation again, and then we're going to look at the charge of each of our molecules or our ions. And from that, that will tell us how many electrons we need to add and to which side. So if we count the charges of each of our parts, we see that both water and antimony have a charge of 0, so the total charge is 0 on the left-hand side. But on the right, we've got antimony oxide and our 12 hydrogens. So that means that those 12 hydrogen ions are contributing a charge of plus 12. So to balance that out, we're going to add 12 electrons in order to balance that out because electrons are negative. Now we'll follow the same process, but we'll do it all in one equation here. So our nitrate turning to nitric oxide. Our main atom is already balanced, so we don't need to worry about the nitrogen. We're going to balance those oxygens, so we'll add 2 water molecules to the right-hand side, and that will give us the 3 oxygens that we need. We've added 2 water molecules, which means we need to add 4 of those H plus ions, and that will give us all of our atoms to be balanced. Then we'll count the charges of our components. So the hydrogens have a charge of plus 4, the nitrate has a charge of minus 1, the nitric oxide and water both have a charge of 0. So we see that the left-hand side is more positive, so we'll add 3 electrons. So we'll rewrite our two half equations and put them together. Now when we're trying to put together our two half equations, we want to make sure that there are no leftover electrons. So when we write out our two half equations, we can see that there's going to be a different number of electrons. So we can't just combine these two equations straight away. What we're going to do is we want these 3 electrons to equal those 12 electrons. A good other thing that we can check is that we have electrons on both sides of our equations, and we can see that we have that in this case. So if we times the top equation by 4, that will give us the 12 electrons that we need. So we're not going to just times the electrons by 4, we're going to times everything by 4. So rewriting our equation, we have now 12 electrons, 16 hydrogens, 4 of our nitrates, reacting to give us 4 nitric oxide and 8 water molecules. So now we can combine our two half equations into one larger equations. So that's what we're having written here. We've got our 6 water, 4 antimony, 16 hydrogen ions plus 4 nitrate, and on the right hand side is our antimony oxide, our 12 hydrogens, our 4 nitric oxides and our 8 water molecules. But now we need to simplify because we can see that we have water appearing on both sides as we do our hydrogens. So we need to cancel out any of those excess ions. So we can see if we cancel out the 6 water and the 12 hydrogens, they're not used up in our reaction. So we can rewrite this equation and write it as a net ionic equation. So those 6 waters and those 12 hydrogens were spectators. So we can rewrite this and replace the 16 hydrogens with 4H plus and the 8 water with 2 water. And that is our final answer. So if you follow the rules for balancing equations, you're going to get very happy because it's the same rule for any other redox equation.